Hello and welcome. In this video, we will see few more examples of constructing context-free grammar for given language. Consider the language L is equal to A. This is very trivial language. It contains only one string, that is A, and that we can directly derive by the start symbol. So S gives A is the CFG for given language. Consider L is equal to A, comma double A. So this language contains two strings. So this is also very trivial. We can directly write down two productions, S gives A and S gives double A. Or we can also combine both the productions into single production by putting the pipeline between the right hand side, that is S gives small a or double A. Consider L is equal to double A, AB, BA, BB. So again, this is a finite language. Whenever there is a finite language, we can put finite that many number of productions into the language. So we can have a S gives double A, S gives AB, S gives BA and S gives BB. So if we have 10 such strings in language, we can have a 10 production. When we have an infinite language, we should use recursive approach to generate the strings. And all these four we can generate, we can combine in a one single production as well. That is S gives double A or AB or BA or BB. This is infinite language. L is equal to A power n, where n is greater than or equal to 0. So if we put n is equal to 0, that will be 0 occurrence of A, that is epsilon. Then we can have 1a, 2a up to infinite A. As epsilon is a part of language, we can add S gives epsilon. And then we have to generate 1a, 2a, 3a, 4a, infinite A. And for that we have to use recursive definition. So we can write S gives A capital S. So if we want 3a, then we will repeat second production 3 times. So we will have a triple A capital S, and then capital S we can replace by the small epsilon. For example, our string is 4a. So we can start with the S gives AS. Then again that capital S in right hand side we will replace by the second production. So we will have S gives double AS. We want 4a. So again we will replace the capital S on right hand side by the second production. So we will have a 3as. Again replace it with the same. And now we know that we don't want any more A after this 4a. So we will use the first production to terminate. So now we have a proper string. The same thing we can derive using the parse tree as well. So we can start with S gives AS, and at every level we will use the appropriate production to generate the symbols, and finally we will read it in order traversal. So we will get 4a. L is equal to A power n, where n is greater than or equal to 1 now. Previously it was n greater than or equal to 0. Here it is greater than or equal to 1. So string must contain at least one A or more A. So solution would be S gives A or S gives A capital S. So using second production we can generate any number of A, and to terminate we will be using the first production. L is equal to A power n, B power n, where n greater than or equal to 0. So language contains all the strings in which number of A and B are same. As number of A and B are same, we can have a 0 occurrence, we can have 1 occurrence, 2 occurrence and so on. So some of the strings are already listed. As epsilon is a part of language, we will start with S gives epsilon. Now we have to first read n number of A followed by n number of B. So we will be writing S gives A S B. So this will ensure that definitely there will be first A, and whenever we generate A, corresponding B will be generated. And whenever we want to stop, we will replace that capital S in right hand side production by the epsilon using the first production. And if we have n greater than or equal to 1, then epsilon will not be the part of language, right? So the smallest possible string is S gives AB, and to generate rest of the string using recursion, we can use S gives ASB. So we will have then 2A capital S 2B, 3A capital S 3B, 4A capital S 4B and so on. And whenever we wish to terminate, we will replace the capital S in right hand side production by the first production. So we will get the desired string. L gives A power n, B power m, n m greater than or equal to 0. You see here the relation between A and B is independent. There is no relation between occurrence of A and occurrence of B. So we cannot write the production S gives A S B. Otherwise that will ensure that number of A and B should be identical. Right? The first thing is that we have to understand whether we can use that recursive production A as B or not. Here we cannot, because number of A can be different than number of B's. So now we are taking capital S gives capital AB. Using capital A, we will generate the first half, that is A power n. Using capital B, we will generate the second half of the string, that is B power m. We already know how to generate A power n, right? So that we have to generate using capital A symbol. So we will write capital A gives A, capital A or epsilon. So this second production will produce A power n. Similarly, for B, I will write down B gives small b capital B or epsilon. This will produce B power m. And when we take the concatenation, that language would be A power n, B power m. And if nm is greater than or equal to 1, then epsilon will not be the part of language, right? That will be simply AB, double AB, A double B and so on. So again, the pattern is same, S gives AB, but now A should not derive epsilon. Instead of that, it would be small a, and in production of B, it should be small b. So that will ensure that there will not be epsilon into the language. L is equal to A power n, B power 2n, n greater than or equal to 1. So the sum of the strings are listed. Here, the occurrence of B depends on occurrences of A. So in this case, we can recursively use A as B kind of stuff, right? But here we want 2B instead of 1A. For each A, there should be 2B. And we have to read first all NA, and that should be followed by 2NB. Okay? So you cannot switch A and B. You cannot read A, then double B, then A, double B. You have to read first 2A, then 4B. So minimum line string is A double B, and recursively we can produce all the strings using the production S gives A capital S double B, because we know that for each A there should be exactly 2B. So we can do that using the second production. L is equal to A power n, B power n, C power m. Some of the strings are listed. The language says that number of A and number of B must be same, and C is independent. There could be any number of occurrences of C. So we can split this language into two parts. Like S gives A, B. Using A, we will derive the first half of the string, that is A power n, B power n. And using capital B, we will derive the C power m. We already knew how to derive A power n, B power n, right? So that would be A gives small a, capital A, small b. Recursively, we can have any number of A and any number of B's. So number of A and B are ensured that they will be same. And whenever we want to terminate, we will replace it by the small a, b. So this capital A will produce the part of the language which is of the form A power n, B power n. And using capital B, we will generate C power m. Now the occurrence of C is independent of occurrence of A and B. So we can have B gives C capital B or C. So this will produce C power m. And this is the derivation. If our string W is equal to triple A triple B C, then we will start with S gives capital A B. Using capital A, we will produce triple A triple B. So first occurrence of, first we'll select AAB. Again capital A we will replace by the same production. And then capital A we will replace by small ab. So we will have a triple A triple B. And using capital B we can generate 1C, 2C, whatever number of C's we want to generate. But in W there is only one C, so we will replace it directly by C. And hence our string is derived. L is equal to A power n, C power m, B power n. So number of A and number of B should be same. C is independent, but now C is in between, right? So we have to make sure that first we will generate same number of A and same number of B, and finally we will generate any number of C. So we can write production like this. S gives A, capital S, capital small b. If we iterate n times, then this will produce A power n underscore B power n language. Okay? So underscore is a blank. We have to replace it by m number of C's. So once we are done with number of A's and B, that capital S we will replace by small a, capital A, small b. And using that capital A, we will be generating any number of C's. Clear? So if we want to generate only one A and one B, then we will start with the second production. If we want more than one A and one B, then we will start with the first production. We will keep iterating it. And then finally we will replace it by second production. And then we will replace it by the third production. So third production ensures that we can have any number of C's which are independent of A and B. L is equal to A power n, B power n, C power m, D power m. So here first half of the string says that number of A and number of B should be same. Second half says that number of C and number of D should be same. So again we will break it down into two halves. Using A we will produce A power n, B power n. We have already done that. So that we can do using A, capital A, B or AB. And similarly using capital B, we will produce the other half, that is C power M, D power M. So C capital B, D or C, D. So that will ensure C power M, D power M. L is equal to A power N, B power M, C power M, D power N. So now number of A and D should be same and number of B and C should be same. Always we should start from the outermost strings. Then we will replace it by the innermost string. So first we'll produce A power N, D power N. So we will do S gives A, S, D. So by iterating this production n number of times, we will be able to produce A power N, capital S, D power N, right? And whenever we want to terminate and we want to generate B power N, C power M, in that case capital S we will replace by the another variable, that is A, capital A, D. So that now using capital A, we are going to generate B power M, C power M. So for that we will write A gives BAC or BC. So that ensures that we can have any number of occurrence of B power M, C power M, but in between A power N, D power N. Right? So the entire string would be A power N, B power M, C power M and D power N. L is equal to A power M plus N, B power M, C power N. So number of A should be same as total number of B and C. So some of the strings are listed. We will break down A into this way. A power M plus N we can write down as A power M into A power N, and I am just rearranging the terms. So we can write it as A power N into A power M, B power M, C power N. So we have A power M, B power M together, and A power N is on one end, C power N on the other end. So we know that how to generate the recursive language for this, right? So first we'll generate A power N, C power N. We will always go with the outermost string. So S gives A, capital S, C. This ensures that we will have a string of the form A power N, C power N. And in between we can produce any string. So whenever we want to terminate, we will replace it by another variable. So S gives A, capital A, small c. And then using capital A, we will generate A power M, B power M. So that is small a, capital A, small b or AB. So this production ensures that always we will have a equal number of A and equal number of B into the string. L is equal to A power N, B power N plus M, C power M. So here number of B's should be same as number of A and C. Let us rewrite B. So that will be B power N plus M. We can write it as a B power N into B power M. So this language we have already derived. So first half is A power N, B power N, that we know how to write, and the second half is B power M, C power M. So we can break down this language into two variables. S gives AB. Using A, we will derive the string A power N, B power N, and using B, we will derive the string B power N, C power M. So how we can do that? We have already discussed, fine, that capital A gives A, capital AB. So using recursively, we can derive A power N, B power N language using capital A. And whenever we want to stop, we will replace it by small ab. And similarly, for capital B, we can write down the production. B gives B capital BC, and to terminate, we will replace it by BC. So this ensures that we will have a string B of the form B power M, C power M. L is equal to A power I, B power J, C power K, where J is greater than I plus K. That means number of B should be more than total number of A and C. So we can rewrite J as like this. J is equal to I plus M plus K, because we want to be B more than number of A and C. So using B power I, we will match number of A's, and using B power K, we will match number of C's, and using B power M, we will generate the additional B's. So that will ensure that okay, number of B's are definitely greater than total number of A and C. So finally our language would be AI BI, then B power M, then CK BK. So finally our language would be A power I, B power I. That ensures that number of A and B are same, then B power M, then B power K, C power K. That ensures that number of B and C are same. So we have some additional M B's in our language, and this we can break down into three variables. S gives A, B, C. Using A, we will produce AI BI. Using B, we will produce B power M, and using C, we will produce BK, CK. So that's quite straightforward. We have done it many times, right? So capital A gives A, capital A, B or epsilon. Using B, we can generate M number of B, and using C, we will generate b power k, c power k. So this is the final language or the grammar. L is equal to a power I, b power j, c power k, where either j is equal to I or j is equal to k. So this is actually union of two language. So whatever strings we have in which either number of a and b should be same or number of b and c should be same. So first we'll derive two language and then we'll take the union of that. So consider the first case, j is equal to I. So a power I, b power j, c power k, we can write it as a power I, b power I because j and I are same. So this we can break into two halves. S gives ab. Using a, we will derive a power I, b power I. We already know how to do it. And using capital B, we will derive c power k. That is b gives cb or epsilon. The second case is j is equal to k. So ai, bj, ck, we can write down it as a power I, b power k, c power k. So again, we will break it down into two halves. S gives cd. Don't use same variable a and b because a and b we have already used into the previous case. Using c, we have to produce a power I. So that's pretty straightforward. C gives either a comma c, ac or epsilon. So using this, we can generate 0a, 1a, 2a or any number of a's. And using d, we have to generate b power k, c power k. So that we have to write down b capital D, c. So that ensures that any number of b's will follow the same number of c. And finally, we will terminate with the epsilon. Fine. And then we have to take the combined solution. So S gives capital AB or capital CD. And productions of AB and CD are already we have derived. So simply that we have to copy here. L is equal to a power I, b power j, c power k. The condition is that I is equal to j or I is equal to k. So it says that whatever strings we have in language, it must have either same number of a and b or same number of a and c. So let us start with the first condition. I is equal to j. So we can write down it as a power I, b power I, c power k, and we can break it into two parts. S gives ab. Using a, we will derive the string of the form a power I, b power I, and using b, we will derive the string of the form c power k, which we already did on the last slide. Second one is I is equal to k. So the grammar would be of the form ai, bj, ci. Now number of a and number of c should be same. So here you cannot break it down into two parts because first and last letter are same now, right? So first we'll generate number of a and number of c's, and whenever we want to stop, we will start producing number of b. So we will directly start S gives c, and using c we will generate a capital C, c. So a capital C small c will ensure equal number of a and c, and whenever we are satisfied with number of a and c, we will start producing number of b. So for that we will replace capital C by d, and using d we will start producing number of b's. So that is capital D gives small b capital D or epsilon will ensure that we can generate any number of d's, any number of b's. And finally, we'll combine the solution. Okay, so S gives either AB or C, and we already have productions of AB and CD on left hand side. So we'll just copy them. L is equal to a power I, b power j, c power k. Either we have I less than j, that means number of b should be greater than number of a, or I greater than k, that is number of a should be greater than number of c into the string. So again we have to derive two strings. The first scenario is I less than j. So b are more. As b are more, we have to break down j into two parts. So we will write j as I plus m because we have to match equal number of b with equal number of a, and we have to have more number of b's than a. So we will break b into I plus m so that we can match ai and bi, and we can also generate some m number of b's. So that will ensure that definitely I would be less than j. Or we can say j is greater than or equal to I. So this we will break into, we can divide it into three variables. S gives ABC. Using A, we will produce A power I, B power I. Okay. That's nothing but A gives A, B or epsilon. Using capital B, we will produce B power M. So this second production will ensure that we have more B's than A. First production ensures that we have same A and B, but we have to make sure that number of B's should be more than A. So we will, using second production, we are generating those additional number of b's, that is capital B gives small b capital B or b. And using C, we will generate C power k. So that is C capital C or epsilon. The second scenario is I greater than k. So number of I should be greater than number of k's. So we will break down I now. Okay. So we will write I as a m plus k, and that we can then simplify as a power m, a power k, b power j, c power k. This we will write down into two halves, because first a power m is independent, and then we have pattern ak, bj, ck. So I'll write it as a s gives pq. Using p we will produce a power m. Okay, that's pretty straightforward. A power ap into or a. By recursively iterating it, we will get a power m. To get a power k, b power j, c power k, we will first generate the outermost strings, that is a power k and c power k. So using q we can write aqc. So aqc will ensure the language a power k underscore c power k. And whenever we are done with number of a and number of c, we will start generating number of b using of production of r. So r gives small b, capital R, or epsilon. So that will ensure the production of b power j. And finally, we will combine all of them. So S gives ABC or PQ, and copy all the productions of ABC and PQR. L is equal to A power I, B power J, C power K, where I less than K or K less than J. So first case is I less than K, means number of C should be greater than number of A. So larger variable we have to break down. Right? So K is greater. So we will write down K as C power I plus M, because we have I number of A. So first we have to match that many C's, and plus we should have some additional M number of C's. So we'll write it as a power I, B power J, C power I plus M, and then we will rewrite it as a power I, B power J, C power I into C power M. Now the first three component into this language, A power I, B power J, C power I, we will produce it using one variable, and C power M is independent, so we will use another variable for that. So whenever we have a power I something, C power I, that we can write it like this: A gives A, capital A, C. So this production ensures that every time we will have, whenever we produce A, corresponding C is also going to produce. Right? So that keeps, so whenever we keep iterating, it will definitely produce A power I underscore C power I. So that makes sure that number of A and number of C are same. We also want to generate now B power J in between. So whenever we want to generate B, we will replace this capital A by capital C. And using production of capital C, we will produce any number of B, that is B, capital C, or epsilon. Using capital B, we have to generate C power M. So that's pretty straightforward. B gives a CB or C. You keep iterating and you will get any number of C's. The second part of language, that is K less than J. That means number of C are less than number of B, or we can say number of B are greater than number of C. So we have to break down J. So we'll write J to match number of C. So we'll write J B as a B power J as a B power K plus M. Then we will rewrite it as a B power M into B power K. So now here we have a power I, B power M, B power K, C power K. So I and M are independent. Right? Only number of B and C are same at the third one. So we will write it down using the three production. Using P we will produce A power I. Using Q we will produce B power M. And using R we will produce B power K, C power K. So as there are same number of B and C, we can always write B, R, C. So that ensures whenever we produce B, corresponding C is also produced. And to stop, we will replace it by the epsilon. And finally, we will take the combination of all these productions. So S gives AB or PQR, and simply copy the productions of ABC and PQR. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.